Good morning, ladies and gentlemen, keynote speakers, delegates, and welcome to the third International Conference on Aligning Sustainability with Vocational Innovations, ICASVI 2026, hosted by Faculty of Vocational Programs, State University of Surabaya. Assalamualaikum warahmatullahi wabarakatuh. Om Swastiastu, Namo Buddhaya, Salam Kebajikan, Rahayu. Ladies and gentlemen, it's my great honor to welcome you here in Surabaya to join the international conference hosted by the Faculty of Vocational Programs, State University of Surabaya, August the 2nd, 2026, live from Surabaya. And welcome to all participants who are now joining both in person at the venue and also online through the conference, online, Zoom online. Thank you and welcome to the conference. I would like to welcome to the delegates and also the invitees. The first thank you to Professor Dwi Cahyokartiko, Vice Rector for Planning and Cooperation, representing the Rector of Universitas Negeri Surabaya. Thank you very much, Professor Dwi Cahyokartiko, for joining us this morning. And also the Dean of Faculty of Vocational Programs, Dr. Suprapto. Thank you very much. The deans and also vice deans, senior faculty members, and also university leaders for the supports. I'd also like to extend welcome to all our keynote speakers who are joining us here in Surabaya. Ibu Professor Dr. Mariam Jamilah binti Ghazali from Malaysia. Thank you very much. Selamat datang di Surabaya, Ibu. And also Professor Dr. Stephen Billet of Griffith University, Australia. Welcome to Surabaya. I'd also like to say hello to our keynote speakers who are now joining online from Taiwan and also from UK. Professor Huang of National Yunlin University of Science and Technology, who is now joining online from Taiwan. And also Dr. Stavros Mikhailos of University of Hull, who's also joining online from UK, very early time in UK at 3 a.m. there. Thank you very much, Professor Mikhailos. And a special keynote speaker also, thank you to Bapak Dr. Benny Bandanajaya as a Director of Learning and Student Affairs at the Directorate of Higher Education, Ministry of Higher Education, Science and Technology of Republic of Indonesia, who is now joining us in Surabaya. Thank you very much, presenters, delegates, ladies and gentlemen. This year's conference embraces the theme of applied innovation for sustainable impact, as sustainability serves as a platform where researchers, educators, and industry professionals exchange ideas, innovation that contribute to a smarter and a more sustainable future. We sincerely appreciate for your participation and hope today's discussions inspire new collaboration across disciplines and borders. Once again, we invite you to round applause to the committee and also the Faculty of Vocational Programs. Ladies and gentlemen, to officially open our conference this morning, may I now invite you to rise to sing the national anthem of Indonesia, Republic of Indonesia, Indonesia Raya, followed by University Hymn of UNESA. Ladies and gentlemen, may I kindly invite everyone to rise.
Di sana aku berdiri.
University Hymns of Universitas Negeri Surabaya. Thank you very much. Ladies and gentlemen, you might be seated. Thank you for your cooperation. Ladies and gentlemen, to extend the warmest welcome to all delegates, participants, and set the tone for today's event, we invite the Vice Rector for Planning and Cooperation, representing Director of UNESA, Professor Dwi Cahyo Kartiko, to deliver the official opening remarks of today's conference. Ladies and gentlemen, please join me in welcoming Professor Dwi Cahyo Kartiko to the stage.
Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera bagi kita semua. Om Swastiastu, Namo Buddhaya, salam kebajikan, Rahayu. Honorable Distinguished Keynote Speaker, Profesor Dr. Stephen Billet, Profesor Maryam Cemila Ghazali, Dr. Stavros Michalos, Profesor Chi Hui Huang, and Dr. Benny Bandanaya Jaya, STMT. Honorable Vice Rector and leader of partner universities, esteemed representative of government institution, industry, and profession associated, respected Dean of the Faculty of Vocational Studies, Universitas Negeri Surabaya, Mr. Suprapto, along with the Vice Dean and faculty member. Distinguished academic, author, reviewer, and conference participant from Indonesia and abroad. Ladies and gentlemen, it is my great pleasure to welcome you to the Dutch International Conference on Aligning Sustainable with Vocational Innovation 2026. On behalf of the Rector of Universitas Negeri Surabaya, who is unable to join us today, I extend his warm greeting and sincere appreciation to the Faculty of Vocational Studies, the organizing committee, our keynote speaker, partner, and all participants for making this conference possible. To share them applied innovation for sustainable impact. Remind us that innovation shall create tangible benefit for society, industry, and sustainable development. Atas nama pimpinan Universitas Negeri Surabaya, kami mengucapkan selamat datang kepada seluruh peserta. Semoga konferensi ini menjadi wadah untuk memperkuat kolaborasi internasional dan menghasilkan inovasi yang memberikan manfaat nyata bagi masyarakat. Ladies and gentlemen, today what Mind University to become driver of innovation and sustainable development. Vocational education play a strategic role in preparing graduates who are competent, adaptive, and ready to respond to global challenges. Through ICASVI, research, education, industry leader, and policy maker come together to exchange ideas, strengthen international partnership, and develop practical solution for a more sustainable future. Komitmen inilah yang luas dan terus diwujudkan oleh Universitas Negeri Surabaya melalui penguatan internasionalisasi, riset berkualitas, dan kolaborasi yang berdampak bagi masyarakat. Finally, I would like to express my sincere appreciation to all keynote speaker, presenter, reviewer, participant, sponsor, and the organizing committee for your valuable contribution. I encourage everyone to make the most of this opportunity to build meaningful collaboration and exchange innovative ideas. By saying, Bismillahirrahmanirrahim, on behalf of the Rector of Universitas Surabaya, I hereby officially declare that International Conference on Aligned Sustainable with Vocational Innovation 2026 officially open. I wish you all a productive conference and every success in your discussion and collaboration. Thank you for your attention. Wallahu muwaffiq ila aqwatim motorik. Wallahu muwaffiq ila aqwamit thoriq. Wassalamualaikum warahmatullahi wabarakatuh. UNESA satu langkah depan. UNESA bersama bisa bersama. UNESA untuk Indonesia Mas 2045. Tepuk tangan kita semua.
Thank you very much, Professor Dwi Cahyokartiko, Vice Rector for Planning and Cooperation, for the opening remarks. I'd also would like to request Mr. Vice Rector to remain on stage as we are going to have a group photograph together with the keynote speakers and university leaders. Ladies and gentlemen, please join me in inviting the keynote speakers, university leaders, and also the organizing committee, the chair of the organizing committee, to join the vice rectors for group photograph on stage. Ladies and gentlemen, today's gathering represents more than a conference. It reflects a shared commitment among universities, researchers, industries, and also policymakers to advance innovation that contributes to a more sustainable future. Through collaboration across disciplines and countries, we continue building solutions that create meaningful impact for the society. So we invite all delegates to look at the camera for the group photograph. UNESA satu langkah di depan. One more, spirit group photographs. Vokasi, vokasi. Thank you. Thank you very much. Thank you. Thank you for being part of this transformation and also where the innovation meets sustainability in line with our theme of today's conference. Ladies and gentlemen, we thank you very much. So we emphasized the point from the remarks this morning, how the vocational education to do international collaborations are expected to give a more meaningful and sustainable impact to the society. And thank you very much, Vice Rectors, delegates, keynote speakers, and also the university leaders for the group photograph. Ladies and gentlemen, thank you very much for your participation and your for collaboration during the opening ceremony of today's conference. We will proceed to the next agenda and we will proceed to the first keynote session. Without further ado, let's proceed the first keynote sessions. In the first keynote session, we have two speakers. One is joining in person here with us at the venue and also joining us online from the UK. The first keynote speaker is Professor Dr. Mariam Jamila Ghazali of University Kebangsaan Malaysia, who is joining us here in Surabaya. And also the second keynote speaker is Dr. Stavros Mikhailos of the University of Hull, United Kingdom, who is joining online from UK. To moderate these first keynote sessions, please join me in welcoming our moderator, Mr. Andra Pratama, the faculty member of Public Administration Programs. Ladies and gentlemen, please join him in welcoming the moderator and also the keynote speakers on stage.
Okay, thank you very much, Professor. And ladies and gentlemen, and distinguished Professor, guest, may I kindly invite everyone to take your seats as we are about to begin our keynote sessions. And first of all, let me introduce myself. My name is Andra Pratama, and I'm from the Faculty of Vocational Studies, the State University of Surabaya. And today I will lead our first keynote session with Professor Mariam Jamila binti Ghazali. So, Professor, how are you? Okay, I hope you enjoy Surabaya and Unesa as well. And I would like to read your CV very short. Professor Mariam is a full professor in the Department of Mechanical and Manufacturing Engineering at University of Kebangsaan Malaysia. She earned her PhD degree from the University of Sheffield, United Kingdom, and has made contribution to research in advanced materials and sustainability engineer. She has also served in several academic leadership roles, such as take role as editor-in-chief of Journal of Kejuruteraan and Assistant Dean for Entrepreneurship and Creativity. Please give she's a round applause, ladies and gentlemen. Okay. And today she will deliver a keynote presentation entitled Reducing Friction, Maximizing Impact, Translating Triological Innovation into Applied Sustainable Practice. And Professor, the stage is yours. My pleasure.
Bismillahirrahmanirrahim. Okay, and Assalamualaikum and a very good morning to everyone. Okay. Can I have my PowerPoint, please?
Okay.
Right. So while waiting for that, okay, let me introduce myself. I'm Mariam Jamila Ghazali from UKM, University Kebangsaan Malaysia. Okay, first of all, I would like to take this opportunity to thank the organizing committee for inviting me. Yeah, and it's such an honor, okay, for letting me to become the first speaker for this conference. So I have my slides, please. And okay, while waiting for my slides to appear, okay, I just want to introduce a bit about my university. Okay, UKM, or also known as the National University of Malaysia, is one of the research university in Malaysia. Yeah, and currently I'm with the Faculty of Engineering and Built Environment. My specialization is in materials. Um, and currently I'm stationed at Research Center of Materials Engineering and Smart Manufacturing, or also known as MERCU. Yeah. Okay. So while we wait for my slides to appear, okay, just so you know that my topic will be um, something very quite general. Okay, I'll try to compile most of my research findings and make it very laid back so that everyone, I mean, the audience can actually understand. Yeah, all good. Okay, okay, take your time. Okay, thank you very much. Right, so as I mentioned just now, I'm from FKAB, Faculty Kejuruteraan and Alam Bina, yeah, Engineering and Built Environment. And currently, I'm the head of MERCU, the Research Center for Materials and Smart Manufacturing. So before that, um, allow me a moment, yeah, to share some good news that we have UKM has received recently. Okay, this underneath you can see all the recognitions so far. So okay, let's start now. So today I would like to talk about something most people actually ignore. Yeah. So imagine whenever you run, whether it's half marathon or even 10 kilometers, yeah, you always feel this pain in your joint, your knee, right? And normally we will blame on our bones or even our joint, but we simply ignore. Actually, is the culprit is the thin and quiet cartilage that actually occurs. I mean, that actually position between our joints. Yeah. So basically, I've spent more than 20 years in focusing this space or interface between this contact surfaces. Yeah. So today's my talk, I mean, because this space is actually where the sustainability lies. Yeah. So my talk for today is called or entitled "Reducing Friction, Maximizing Impact." Yeah. So hopefully by the end of my talk, you'll never look at your own joints or whatever space. Yeah. The same way again. Now, next, please. So first, next. Next slide, please. Thank you very much. Okay. So now, first, let us start with money, yeah, because that's what normally gets attention. Yeah? So you can see that friction quietly adds 20% increase in fuel costs. Yeah. And then 8% of total industrial maintenance budgets also consumed by wear and tear. Okay, these are the culprits. And then we have 0.25% of Western GDP actually lost to tribological inefficiencies. Okay, I'm sorry because I couldn't get the data for Southeast Asia GDP. Yeah, I only counted Western GDP. Yeah. So this is actually the hidden problem on the machine, you know, on the planet. So next slide, please. So what exactly is the hidden problem here? Yeah. So this is what we call it as tribology. Okay, some may call it as tribology, some may call it tribology. So tribology is actually the science of wear, friction, and lubrication. Yeah. It may sound, I mean, it may not sound glamorous, but it actually decides how long your components or your machines actually can last. Yeah. So from you brushing your teeth in the morning, okay, all actually involve tribology because the word tribos originates from, it's a Greek word that literally means rubbing. Yeah, so from the moment you brush your teeth until, the operation of power turbine, it all involve tribology. So, and according to Holmberg and Eldemer, even though their findings is in 10 years back, but it's still valid until today. Yeah? So, more than 25% of the world's energy is actually lost due to this friction and wear problems. Yeah? Okay, next slide, please. So, as I said, 25% of global energy has been simply lost or rubbed away. So this is not just an engineering problem, okay? It's an economic crisis. So by mastering the surface engineering, we are not just saving that the components or the parts, we are actually saving billions, yeah, of rupiah or even dollars in maintaining an energy cost, yeah, across every industrial sector. Next, please. So how are we going to fix this? Yeah. So we can actually group this solution into 3 areas. You can see the green manufacturing, advanced materials, and also energy harvesting. So as you can see here, basically these are the outline of my talk today. Next, please. Right. So let us start with green manufacturing. So whenever we're going green, usually it will hit a wall. Yeah. Okay. Let's look into the mineral oil first. Okay. So we know that flat mineral oil normally it will cool beautifully, but it is toxic, and the fluid usage is very very huge amount. Yeah, almost like 1,200 liters an hour. So now we already switched to vegetable oils. Okay, as you can see, the MQL, minimum quantity lubricant. Okay, even though the usage is quite smaller compared to the mineral oil, okay, and I mean the drawback is it's insufficient. Why? Because it evaporates rapidly. But now recently we have switched to nano vegetable oil, okay, known as nano MQL. So you can see the usage is very very small quantity, and the cooling is very good because it's drastically boosted, and the most important thing is it's very eco-friendly. Yeah. So the honest question to the industry avoid. So can we actually keep this biodegradability and still get the cooling? Yeah. So that gap is what my lab actually set out to close. Okay, next, please. So this is where it gets interesting. First of all, I would like to give credit to my research friends, research team. We have this collaborative research going on with University Negeri Malang, yeah, led by Professor Poppy. So you can see here, we know that Indonesia has, so many tons of shellfish, yeah, produced every year. So from that waste, we actually wash and dry up to 200 degrees C, and then we wet ball mill it, okay, up to 40 hours and become micro powders. Then we synthesize it with this what CaCO3 crystallite, yeah, the calcium carbonate crystallite, until it reach about 52 nanometers, and then we stir it with it. We add it with corn oil base. Okay, next, please. So now let's look at the results. So with just 0.15% of concentration, okay, we actually can see this tool wear drop, okay, about 36%, okay, surface roughness, and then a drop by 28% sorry, tool wear drop is about 36%, and the surface rough rate actually drops to 28%, and also the cutting temperature drops 22%. And if we look at the thermal images down there, you can see that how the dry cutting actually shows a blazing hot spot, okay? And when we actually involve this nano cutting fluid, okay, by using this waste of the shellfish, you can see the difference, okay, of the thermal area there. So when we look at the tool itself, yeah, the huge difference between the conventional tool and the one with this nano fluid, right? So you can see that by only using 0.15% of concentration, okay, we can actually improve very, very, big and promising thing for the tool wear, right? Okay, next please. So how does this actually work? Yeah. So basically, we have categorized into four mechanisms. Okay, we observe that there are four mechanisms that occurring, and the first, as you can see, the first one is rolling effect. So you will see that the rolling effect, where the nanoparticles will act like a tiny ball bearing, which they will convert all the shear friction into smooth rolling contacts. And then we also have the mending effect, yeah, where the particles physically fill up the micro cracks as they form, and they also act as a protective film, okay, that forms under pressure. Yeah, so it keeps the metal from touching onto one another. And finally, they also give this gentle polishing effect, yeah, that can smooth up the final surface. Next, please. So basically, we have solved the fluid problem, okay, by adding all this waste product, okay. So that's why I put it just now, waste to wealth, yeah. So now let's talk about the surface itself, okay. And to design a better surface, we're going to leave the lab and let's go outside. Okay, next slide, please. Now, so when I said outside, it means that we have to embrace, okay, and appreciate our nature. Yeah, you can see here, nature has been there since, before we are born, right? So basically, we can actually learn so much from our own nature. So if you can see that there's a verse in our Holy Quran that says that it reflects upon the creation of the heavens and the earth. So it's actually, as a Muslim engineer in particular, we have to make some discoveries, yeah, and learn all the living things around us, yeah. So it's not just spiritual; it's literally an invitation to discovery, especially for sustainable design. Next, please. For instance, let's take the snake scales, yeah. We know that snakes, they have no legs or limbs, but every time they slither or slide, okay, on any surface, they won't have any blister or whatnot, right? So they actually can move effortlessly and resist sliding, and of course they will only go one way but cannot go backwards, reverse, yeah. So this kind of knowledge, okay, can be actually learned, and we can actually mimic this, and we can adapt in our conveyor belt, yeah. So this is what we call it as a ratchet mechanism. So imagine that if you have to bring one big chunk of rocks or whatever weight, okay, from one place to another with a very steep climb that needs a steep climb, so you can actually do it effortlessly, okay, meaning that you can save energy there, right? So it shows that the nature already solved the problem, a one-way friction problem for us. Okay, next please. So this is what we call as a biomimicry. Yeah, we try to mimic. We borrow whatever things that happening in nature, and try to benefit to our daily life. Yeah. So basically, in biomimicry, we actually discover this nature's principle. Okay, that but that one is easy part. I mean, discovering the natures is easy part, but to materialize it and to make it or to copy exactly the same, that will be very very challenging. Okay, because our so far our best 3D printer only reaches about probably up to 10,000 nanometers. Yeah, but if you can see, even the lotus bumps on the lotus leaf, yeah, is about 100 to 200 nanometers. Yeah, so it's like 1,000 times thinner than our human hair. So it's very challenging in order to copy exactly the same texture, okay, on whatever surface you are working on. Right. So next slide, please. So how are we going to actually put this nature's texture or patterns, let's say, on our desired samples like steels or polymers? Yeah. So basically, the closest that I can, me and my team actually can get is by using laser surface texturing. Yeah. Even though we cannot obtain up to nanoscale, but still we can obtain up to micro scales. Yeah. So the procedures are, as you can see, the first step is, of course, you need to identify, okay, the bio-inspired pattern, whether it's groove, dimple, or even a chevron shapes, and then use the LST, the laser surface texturing, to engrave that micro textures. Yeah. Okay. You can see there the illustration is in Malay language. Okay. Next, please. So basically, we didn't just pick one pattern and hope. Yeah? We systematically tested, yeah, all sorts of texture and patterns, okay, on several materials. So the goal here is simple, okay, whether which here, I mean, we have to know which texture actually suits best for the right application. So it takes actually years of testing, yeah, to get that answer. All right, so next, please. So I just want to share you some of our findings. We have conducted this laser surface texturing on ceramic coated metals. So you can see there is the results are very, very promising. We found out that somehow it can actually have this increase more than 50% for erosion resistance, yeah, and up to 70% increase of corrosion resistance by using that texture. So it's very promising, yeah, if you compare to the one without any texture. So next, please, slide. Right. So how does all this texture or this groove actually protect against corrosion or also erosion? So let's take this illustration. So actually there are two mechanisms happening. The first one is the formation of the air pockets. Yeah, the air pockets actually trap inside the groove. Yeah, physically will prevent all these corrosive liquids. Okay, for instance, if you put your sample in seawater, yeah, salt water, so it will actually prevent corrosion liquid from getting full contact, yeah, with the metal underneath. And then at the same time, the texture or the groove will disrupt the particle erosive wear, yeah, through the turbulence control. So you can see here, in the end, it will actually slower or slower the ion penetration, and at the same time, it also act as a cushion of air. Yeah, so it's very very good if you compare to if we apply expensive coating. Yeah, so this is one of the ways in order to not just protect the material but also to save cost. Right. Okay. So next, please. Yeah. So before we proceed, let us pause and connect some dots. Yeah. So we have talk about what just now waste to wealth on the what the waste she-shell fish that I spoken just now, the one that we have research collaboration with the University of Malang, and then I've talked about the surface texture, how we actually mimic nature's texture, and where we can actually save costs, save energy. And now let's talk about, I mean, how are we going to conserve this energy? Okay, because everything will relate to sustainability. Because when you relate to true sustainability, it's not just about getting that what greener energy. It's, basically, it's the physical reality of how materials actually touch each other, right? So that we can actually mitigate all this friction and wear problems. Okay, next please. Okay, now let us shift our gears, completely from machining just now to energy. So nowadays we know we are into this IoT with the AI, so it needs billions of distributed sensors. So for powering all these sensors, okay, of course some of them will need batteries. Okay, so we know batteries are not sustainable. Okay, it's toxic. It can create this huge e-waste. So it is our task, in replacing all these billions of batteries forever. Okay, so we need a different answer. So next, please. Right, so this is where TANG, if you heard about this, tribal electric nanogenerators, TANGs comes in. Okay, so in UKM currently we are focusing into TANG. So you can see that TANG actually can harvest ambient motion, okay, via friction into electricity. Okay, so no battery actually needed whatsoever. So it sounds perfect, but there are so many challenges there. You can see that with time, okay, if there's no preventive measure between the contacts, of course it will deform, and of course the topography will collapse. Yeah. So the device that actually powers itself also wears, okay, to death. So that's the paradox we had to solve. So next, please. Next slide, please. Okay. So here we also have studied this. We say about lubricants. Yeah, as I said just now, tribology is a science of wear, friction, and lubrication. So we have turned the field into this. We opt for solid lubrication, and here comes in Maxine. Okay, this Maxine here is actually a two-dimensional transition metal carbides. Like you have this titanium, titanium, carbon, and TX. The TX there is actually a terminal surface groups, such as you can add either OH or fluoride or even the oxides. Yeah. So just look at this publication graph. You can see that over 600% of growth in a decade. So this is not just a niche interest anymore. It's a paradigm shift in the materials science. So we now are using this Maxine as our solid lubricants. Okay, next, please. So basically, this is our findings for the past few years. So here's why as I said, Maxine actually can work. Yeah? Why? Because it can disperse onto our sliding surface, and this two-dimensional will act as a nano sheet. It will create a highly adhered protective layer, just like a deck of cards. Yeah, so it will slide against each other. Okay, under with extremely low shear resistance. So just look at the wear rate data there, okay, on the right-hand side. So you can see that the comparison between the plain one, okay, and the one if we add Maxine, alumina, and also Ti3 C2 TX there. So it drops drastically. Yeah? Okay, next please. So this is actually the architecture that we are currently building in our project in UKM. So you can see that the titania nanostructures will act as a charge generators, and the Maxine just now in the nanosheets form will act as a conductors and structural reinforcers. Okay, so it all embedded in the polymer matrix. So this two-dimensional Maxine will act as a solid lubricant inside the device itself. So it will dissipate, or it will spread out the shear stress before it can micro crack the surface. So we're not just harvesting energy, we actually engineering the device, okay, so it can survive on its own. So next, please. So here is the proof. Okay, this is actually one of my colleagues' findings, Dr. Uy. So if you can see the dotted lines, yeah, in the first one, the dotted line, is actually that is a conventional tank, the triboelectric generators. So you can see that that dotted line shows that there's like a spike, yeah, in the beginning before it collapses as the surface flattens under abrasion. Okay, in comparison to the one that when we actually include Maxine into it, you can see that how it reaches like a steady state, okay, and become and holds like a plateau, okay, and it can sustain up to 10,000 operating cycles, right? So next, please. So as take-home message, yeah, let me bring this together in three, I would say, sentences. Yeah, number one is rethink waste. Like us in Indonesia, Malaysia, we are in the same archipelago. We are actually blessed with abundance of natural resources. Okay, just like what we did with Nusa Malang, we actually use the waste from shellfish. We grind it into nano powders and put it. We add a bit of corn oil and become a very good lubricants. Yeah, for tool wear. And then number two is engineer for survival. So you can see that initial power output is meaningless if the material cannot survive more than up to 1,000 cycles of physical friction. So this is where we opt for Maxines. Okay, and finally, tribology. Okay, the science of wear, friction, and lubrication is actually the sustainability. Okay, because by minimizing the friction, okay, we can actually maximizing our planet's resources. So next slide, please. Okay, so when it comes to implementation, yeah, of course we need to embrace, okay, all the challenges and try to bridge the gaps. Yeah, so we know that like traditional tribologies or technologies, okay, normally they are normally just trained for reactive maintenance. If the parts fail, they just simply replace the parts. Yeah, follow SOP, the standard and whatnot. Yeah, but that model is no longer sufficient. So now we tend to go towards green typologies or green technologies. Yeah, where it must, one must needs to have a fluency in preventive tribology, okay, circular materials life cycle, and has its judgment to cut the entire facilities, okay, especially when it comes to carbon footprint. So, which is why I put it plainly, sustainability is not about a technology problem anymore. It's actually a training, yeah, a training problem, especially when it comes to vocational education. This is how we actually solve it, yeah. And I would like to take this opportunity again to introduce you to our society, as this is actually one of our initiative in Malaysia. And for information, I'm also one of the co-founder for the Malaysian Tribology Society. So we have our society. Initially, we just want to have this improved awareness among the public, okay, especially for the universities students. But now it has become quite big, and I actually welcome you all, okay, because in Malaysian Tribology Society, my tribos is not just for Malaysian, they are actually open for everyone, okay, to join.
Professor, this is a gentle reminder. Your time is 5 minutes remaining.
Okay, almost there. And again, I just want to share with you that we also have our own journal for this tribology, and it has been Scopus Index. Welcome to submit your papers if you like. And again, as you can see, just want to share with you, okay, some information on the World Economic Forum's top emerging technologies, so that you can actually embrace what's actually going on. Yeah, for information, all these three. Oh, sorry. Next slide, please. Next slide. Yeah, this is our own journal tribology that has been Scopus Index. Next slide, please. Okay. Yeah, so as you can see there, all three emerging technologies are basically involve surfaces. Yeah. the spaces that between those two contact surface. Next, please. Right. So I will leave you with this thought before I end my talk. Yeah. So ultimately, if we reduce physical friction in our machine, okay, normally must be paired, yeah, with reducing the skill friction in our workplace. Yeah. In order to maximize our impact, of course. And with that, next slide. I think this is the final slide. Yeah. Then that's it. So so are you ready to innovate? So thank you very much for your low wear and sustainable attention. Okay, right. Thank you.
Thank you very much, Professor, for your presentations. Okay, I invite you to join with us. Okay, so Professor, this is a very interesting because I encounter a new word which is tribology. As well, I assume that when the sustainable approaches can do in every country, maybe we can increase the production fees to every single industry. Okay, Professor, so we will next to the second keynote speaker and you can stay there. And after the second session, we're gonna do some discussions. Okay, ladies and gentlemen, and we now going to our second keynote speaker. This is a very special because our second keynote speaker joining us from the UK, but we invite him via teleconference. And may I see that screen? Mohon maaf, apa sudah ready? Okay.
Yeah, hi everyone. Good morning. Can you hear me?
Good morning, Professor.
Good morning. How are you?
Okay, I'm very good. I'm wonderful. Okay, thank you very much. Thank you very much, Dr. Michaelis. And ladies and gentlemen, it's great pleasure to introduce Dr. Straval Michaelis, a lecturer from the University of Hull, United Kingdom. His research focus on low carbon energy systems, carbon capture, sustainable aviation fuels, and biorefineries with over 50 publications and extensive experience in sustainable energy research. And he has made a significant contribution to advancing innovative and sustainable energy solutions. And right now, Professor, are you ready?
Yes, I am.
Okay, Professor, the screen is yours. Please take your moment.
Just a question, please. Regarding my slides, am I expected to share my screen or because I cannot see my slides right now? Yeah, brilliant. Yes. Okay. Yeah, good morning, everybody. Many thanks for the invitation. So glad to give this presentation. I wish the lighting in my room to be better, but anyway, please bear with me. Yeah, again, thanks to the committee for the invitation. And today we'll be talking about our research here at the University of Hull, focusing on deep decarbonization in waste to energy and hydrogen production plants through carbon capture and storage. Yeah, you can move to the next slide. Thank you. Uh, there are going to be two main sections. The first one will focus on post-combustion CO2 capture. We'll talk in a bit what this technology does, and we'll talk about high capture fractions fitted to several, it can be fitted to several industrial plants, but today's presentation will focus on energy from waste plants. We'll talk about techno-economics and LCA, and then about hydrogen. Everybody's talking about hydrogen, so we'll present here some innovative ways to produce hydrogen with multi-product generation and using again waste as feedstock, and we'll talk about again life cycle assessment and techno-economics. Yeah, please, next slide. Now, In general, carbon capture is about separating CO2 from flue gases, either from fluid sources or from directly from the air. But within this codex, we will focus on flue gases. Based on recent reports, CCUS is a necessity and not an option for net zero targets that have been implemented across the globe. Post-combustion capture or using amines will be the most widely used flue gas capture technology, and our research focuses on optimizing these technologies. And as I mentioned, the post-combustion offers the advantage of retrofitting existing infrastructure. So you have a power plant or an energy from waste plant, a cement plant, a steel plant. You can easily fit post-combustion capture to these existing plants, and obviously can be also applied in new builds. And well, it's a consensus, but in my opinion, also is the most cost-effective solution for decarbonization in hard-to-abate application, such as steel, cement, and energy from waste. Yeah, please move on. Next slide, please. Thank you. Now, I will be talking about my recent research over the last maybe 2 3 years on post-combustion capture. So, uh, two main challenges we face. We try basically to overcome. One is high capture fraction. Successful deployment of post-combustion will rely a lot on high capture fractions. Okay, and we focus on fractions of more than 95% up to 100% of the added fuel CO2. So far, up until at least the last 5 years, the consensus was that any capture fraction above 90% is just very expensive. And this was one of the myths that we try to debunk through our research. Also, we focus a lot on designing and analyzing solvent management strategies. So, what is this? Basically, the solvent that circulates in the plant that captures the CO2 has to be refreshed, okay, has to be reclaimed. Uh, if I have to give an analogy, imagine the oil engine in your car. It has to be replaced every now and then after 5 6,000 miles, whatever. Now, in our case, we cannot, we should not basically fully replace it, right? Because it's going to be very expensive. So we need to find ways in order to remove the impurities that they are developed during the operation of the plant. The work we have done was initially modeling, theoretical. We have used some specialized tools dedicated for carbon capture, such as the Aspen CCSI. And we have collaborated also in big engineering fit studies that dealt also with the design of post-combustion capture plants. Next slide, please. These are the process flow diagrams for those with not an engineering background. Basically, it's a schematic of how plant looks like. So the first one, the top left, is a schematic of the post-capture plant. So basically, you have the flue gas that comes from the operations, energy from waste or coal plant, natural gas plant, or whatever. The first unit, the absorbent, is basically where the solvent is being in contact with the flue gas, and the solvent can selectively absorb chemically the CO2. Then it exits the absorbent from the bottom, goes through some heat integration units, and then goes to the desorber. In the desorber, with the application of implementation of energy, we can separate the CO2 that exits at the top, and then this CO2 can be liquefied and stored permanently at the ground. Now, regarding the solvent reclaiming, we have investigated two configurations, one single and one dual stage operation. Uh, Again, the idea here is to purge some of the lead solvent, as you can see in the first graph, and send it to this plant, okay, uh, in order to recover clean solvent with the addition of steam, doing traditional engineered technique, the steam stripping. And this can be done either in one stage or two stages. The clean solvent then can be sent back to the post-combustion plant. And also with this technique, we can also recover the energy we spent, or most of it, as we will see later. Next slide, please. We have done some thermodynamic analysis at the beginning, focusing on 95% capture in order to identify operating windows. And what we found is that there is a strong connection between the lean loading. Lean loading is basically how concentrated is the solvent, okay? Sorry, how much CO2 is existing to the solvent, and the pressure that the desorber operates. So uh, we identify this inflection point here, all right, for different operating pressure. This lean loading is lower, and this was quite important for high capture fractions, because the lower the lean loading, the higher the mass transfer, and this allows us to capture more CO2. The penalty obviously is because we are operating at higher, not much, but still higher than usually. We have to spend more energy in the desorber, but we will see this difference is not much. So again, the key highlight of this is that ultra high capture fraction require balancing lean loading and stripper operation. Stripper is the desorber. One key outcome of that is that these are the process parameters that can be easily adjusted and monitored in operations, even large scale operation and pilot scale operations. Next slide, please. So now what we did is, after we did this, identified these operational windows, is to apply these techniques on several case studies. Okay, CCGT stands for combined cycle gas turbines, cement, steel refineries, and energy from waste. Initially for 99% capture. We'll talk later why not yet 100% capture. And we can see that the optimum specific reboiler duty, which is basically how much energy we need to separate the carbon dioxide, is around 3.5 to 3.7 gigajoules per ton of CO2 for all cases. And I should highlight here that this range lies within the range of lower capture fractions of 90%. So our design basically does not increase by a lot the energy that we consume. Next slide, please. Then what we did again, we want our simulations to be impactful. Okay, so we did some analysis of key process parameters that can be applied in pilot operations. Uh, we have tested our designs uh, in pilot scale in Sheffield in the UK that reach around 1 ton of CO2 per day, and also in China a bit bigger pilot plant that reached 50 tons of CO2 per day. And we could see that in both cases, the results of the pilot plants really they were in great agreement with the modeling results. Uh, so basically here what we do is, call it a corner graph, and we want to identify what's going to be the ideal liquid to gas ratio in order to capture high amounts of CO2, 99% here. And this is basically the liquid to gas ratios because the gas input is constant. Basically, tell us how much liquid, how much solvent we need to supply to the system. Again, it's quite crucial because this is a process parameter that can be easily adjusted and monitored in operations, in real world operations. I talked at the beginning about 100% capture, and so far, based on these designs, we couldn't reach it. We could get a really close 99%, but the closer you get to perfection, the harder it gets to reach it. And so, in order to do that, there are two ways. One is called intercooling. Basically, in the absorber, you can cool the solvent, or as we talked before, go to even lower lean loadings, but further increase the pressure in the dissolver. We didn't want to do the latter because this will increase the degradation of the solvent. So we did the intercooling, and next slide, please. You can see here the temperature profiles, okay, of the absorber. On the left, there is no intercooling, and I say here that it's become full thermodynamically. Okay, basically, it cannot absorb anymore, even if chemically it still has some capacity. And what you can see here is the blue and the orange, which is the equilibrium and actual CO2 pressure. They are kind of close to each other, which means that there is no good mass transfer. But with intercooling, you can see that this gap gets wide, which enhances the mass transfer and allows more CO2 to be captured. Next slide, please. And so with this intercooling, we can capture 100% of the CO2 that's contained in the flue gas. And I have here for all cases, again for 100%, you can see that is very reasonable energy penalties, all of them below 3.8 gigajoules per ton of CO2. And you can see if we compare this energy penalty, for example, for the energy from waste scenario, between 100% and 95%, you can see the increase is only how much is that? 5%, I guess. Between a low capsule fraction and the 100% capsule. Next slide, please. Now, what the thermal reclaiming Again, thermal reclaiming is all about removing the impurities from the solvent and recover clean solvent and return it to the capture plant. We get degradation data from real operations from TCM in Norway, and we design a system that treats solvent continuously. We have added to the model both the two different types of degradation products, the oxidative that mostly happens in the absorber and the thermal that mostly happens in the desorber. And we can treat the whole inventory of the solvent in 21 days. And throughout this operation, we haven't exceeded the critical threshold as identified from the operations in Norway of 7 point, sorry, 5.7 for mass concentration of degradation products in the solvent. Next slide, please. Now the results, as I said, we do have two configurations, one stage, single stage and dual stage, and we add also water basically to enhance the recovery of the solvent of the MEA in our case. And we have noticed that increasing the water addition and temperature increases both MEA and HIDA. HIDA is the main degradation product. This is something that we don't want to recover, but in any kind of separation, there is this trade-off between selectivity and recovery. The single stage reclaiming can achieve the highest recovery of solvent of MEA up to 97%, but we recycle a lot of the unwanted degradation product, the HIDA. On the other hand, the two stages achieve a very good MEA recovery, okay, on average 90%, and with substantially lower degradation uptake between 23 and 30%. And for the dual stage, the model predicts that the concentration of this product is up to 1.4% of the solvent, which is quite low. So, our future research will focus on dual stage configuration. And I have to highlight also here that this modeling work also informed the setup of a lab at the University of Sheffield, which we collaborate with. Next slide, please. Now, the thermal reclaiming basically involves boiling stuff. All right. Now, boiling means that we have to spend lots of energy, but our configuration is able to recover this energy and send it back to the post-combustion plant. And you can see that the equivalent electricity loss is very low. Okay, so around 0.8% increase, which means that without the thermal reclaiming, the energy loss was 41.35 megawatts, and with the addition of the thermal reclaiming, this only increases to 41.7 megawatts. Next slide, please. Now, all good economics, but everybody's asking all good about the technical, but everybody's asking about the economics. We did also techno-economic analysis, and we compared the 100% capture with the 95% capture, which is appears to be the new benchmark, at least in the UK, but also in the US for sure. And we compared these two case studies. First, we calculated the capex. Next slide, please. The OPEX and also the levelized cost of CO2 capture, which is an economic indicator that combines CapEx, OpEx, the discount rates, project lifetime. Basically, is the most representative, meaningful economic indicator for the CO2 capture, and we can see that. The increase from 95 to 100% is only 4%. So from a cost of 78 pounds per ton, we have for 95% the full capture, 100% capture increases only to 81 pounds per ton. Next slide, please. Now, what about the cost of capturing only these 5 last percent? This is for two different absorber heights. For 20-meter absorber height, this one is around to 175, and for 24-meter absorber, this is 141. Now, these are capturing the residual emissions. We have to compare it with a technology that basically serves the same service, such as direct air capture, for example. Okay, which is basically a technology that can suck the CO2 directly from the air. Now, the cost of DAX varies a lot, but is typically based on the literature between 300 and 1,500 pounds per ton. So we can see with our design, if we push the post-combustion plant to work a bit harder, makes much more economic sense than applying direct air capture. We have done also some policy analysis. The UK ETS is basically the trading scheme for CO2 in the UK, and we have basically I try to explore if the 100%, if there are any market conditions that will make the 100% capture more cost effective than the 95% capture. So we did this sensitivity analysis for the electricity price and the CO2 price. Now, the 100% capture, obviously, you don't have to pay anything. So it has zero exposure to the ETS. But at the same time, because it needs a bit more energy, we waste some of the electricity that the power plant produces, so we have a loss of revenue over there. So yeah, bottom line is that even if it's narrow, you know, there are conditions, low electricity price and high CO2 prices, that 100% capture can make sense even from an economic point of view and not only environmental. Next slide, please. Yeah, this is just the two papers that authored with colleagues and also industrialists from Bechtel, SSE, and you can check, just put them if you want to check the details of what I presented so far. Next slide, please. Now we'll talk about hydrogen. Everybody's talking about hydrogen, and rightfully so to an extent, as hydrogen will be essential to decarbonize several industrial sectors. Some of the challenges of low-cost, low-carbon hydrogen, such as green hydrogen from water electrolysis, is that it is super expensive. It is really hard to reduce the cost, mainly because of the expensive feedstock, which in this case is electricity. So we need to investigate, to explore processes that utilize low-cost feedstocks. One of that is waste. It can be municipal solid waste, food waste, plastics. to produce hydrogen and ideally, if possible, other products. Now, if we utilize waste, we kill two birds with one stone basically, because we do both waste management and energy generation. Next slide, please. Uh, so, we did some work with one of my former students that is now lecturing in Indonesia, Nina. So we did a modeling study of investigating MSW to hydrogen, and the system can also produce cooling, heating, and power. The proposed system is based on actual waste composition data from one of Indonesia's largest landfills. I will definitely mispronounce that. Binowo, I guess. And the plant reaches two waste streams: plastic, which is gasified, and the food waste that it is digested. Next slide, please. So Nina constructed this really complex process flow diagrams. Okay, we investigated many scenarios for pre and post combustion using again exhaustive process simulation, ASPER Plus and MATLAB. When applicable, we compared our results with actual data, also energy and exergy analysis, and process and heat integration. Next slide, please. Uh, in short, for each scenario, we investigated also three case studies. The first one basically treats the two waste separately. The plastic waste is gasified, while the food waste is sent to an aerobic digester. The second case study assumes that both plastic and food waste is gasified, and third case study, the plastic and the food waste are treated separately. Now, biogas is the product of digestion, and in our case, in the third case, we have assumed that this biogas is sent to a steam methane reformer, which is basically a unit that converts biogas to hydrogen. And the idea behind doing that is to increase the hydrogen content. Next slide, please. We have done also techno-economics and LCA, and again, in this case, the main economic index is the levelized cost of hydrogen, and you can see that almost in all cases the scenario one outplays in terms of cost the scenario two, but in terms of environmental performance, we have examined here the global warming potential, which basically summarizes into one index all the emissions to the atmosphere and present them as in kg per CO2 equivalent. We can see that in this case, that scenario one clearly outplays scenario two outplays scenario one, and we identified here a very distinct trade-off. One process seems to be more cost-effective, while the other one seems to be much more environmental friendly. Next slide, please. We did also again a policy analysis and investigate the levelized cost of the hydrogen as a function of the carbon credit and the energy incentive tipping fee, basically a gate fee that people pay to a waste plant to manage their waste. And the black note denotes the current Indonesian levels of 8.9 USD per ton of CO2 and 14 USD per ton of waste, while the red dot match USA benchmark a bit more generous with 85 USD per ton of CO2 and almost 57 USD per ton of waste for the gate fee. You can see for the scenario one, for example, if we use the current Indonesia level of subsidies, our hydrogen product is higher compared to the competitive blue hydrogen and the gray hydrogen, but it is cheaper if we apply the USA, at least the current, let's say, the current USC level of subsidies. Similar story for scenario one. With the current Indonesian levels, we are way far from the competing hydrogen technologies, and but with the American levels, we can compete with the gray. We are better than blue hydrogen and almost same level with the gray hydrogen, which I have to say here that the gray hydrogen is the dead hydrogen. Okay, it doesn't have any CCS and it's, have lots of CO2 emissions associated with its production. So yeah, basically this, our job as engineers is also to inform policy and, suggest what sort of a level of policies we need to make a process viable, and then leave it to them to make a decision. Next slide, please. Yeah, again, this is a summary of Nina's work during her time in Sheffield, where she was doing her PhD, and I was doing my postdoc, and I had the pleasure to supervise her. So you can find more details in her, yeah, I guess, relatively recent papers, and obviously you can contact her or myself if you need more details. Next slide, please. Yeah, basically to sum up, net zero or 100% capture, we have showcased and demonstrated in actual operation that is achievable. Our reclaiming design also shows good results with good MEA solvent recovery and low recycle of unwanted degradation products, and can be affordable. As we showcased before, there might be conditions that makes sense from an economic point of view to operate the plant at 100% capture. Next slide, please. Now, regarding the hydrogen, we have showcased that the multi-generation system can improve the energy and technical efficiency of the plant. We have identified this interesting trade-off between cost and emission criteria for different scenarios, but also the effect of different policies. And we believe that under certain circumstances, technical and policy, hydrogen from waste can be produced at very competitive prices, and at the same time to manage waste. I have added some other slides. I'm not sure if it's updated. If it is not, it's fine. Next slide. Okay, you updated it. Splendid. So, a bit about the vocational innovation that we try to implement here at the whole university. First of all, why needed? Because there is a rapid scale up of CCUS, especially in the UK, that we want to be one of the global leaders, not only in research but implementing actual large scale plants. So, CCUS requires thousands of engineers, technicians, operators with specialized skills, and typically up until the last few years, I guess, or this is a common thing across the world that many academic programs, even engineering, often emphasizes on the theory, on the physics, but provide limited exposure to industrial cases, US systems. Uh, Now, the future engineers should not only understand the technical aspects, but they should have a good familiarity and acknowledgement of the whole value chain, storage in terms of in the CCUS, all aspects of the technical aspects, but also the economics, policy, environmental effects, etc. Next slide, please. So the students should graduate with experience in modeling tools, okay, state-of-the-art modeling tools. I mentioned here some, Aspen Plus, Aspen Hysis, CFD, AI, machine learning, process optimization, data analytics, monitoring and control. And what we try to do here is to uh, try to transfer to the student a way of thinking which is system level thinking and not unit operation. Um, we mentioned before about technical indicators, for example, energy consumption, etc. Energy consumption can be only one indicator. There are so many other parameters that can be influenced by the design of the plant, and uh, the students should be able to do a multi-criteria analysis and decision making when it comes to engineering design.
Okay,
Next slide,
Doctor, I'm so
please.
sorry, cut your presentation. You still have 2 minutes left.
Okay, I will speed up. Thank you. Next slide, please. Yeah, as I mentioned, they need to develop decision-making skills. They should be trained in techno-economic, life cycle, risk and uncertainty analysis, policy evaluation, business models for the CCUS. Next slide, please. So how we do that? We have several industrial CCUS case studies. We have a final year design project, but also MSc thesis that they are done in collaboration with local industries. Okay, and many of these projects are related to CCUS. We have multidisciplinary team projects. Okay, we collaborated with people from business school, from supply chain and logistics, and we develop our digital engineering skills through dedicated workshops in Aspen Plus on techno-economics, life cycle. We also collaborated with the computer science. We do modules together about AI and AI optimization, and also the development of digital twins. Next slide, please. Lots of industrial engagement. Whole happens to be in the middle of the core of the biggest industrial cluster in the UK. We have many guest lectures from CCUS developers. This can be operators, technology suppliers, policy makers. We do have industrial placements throughout our curriculum, and joint supervision of student project with the industrialists. And we also started to offering CPD training, okay, for example, process safety, hazard, risk assessment, and our goal is to create graduates that they are job ready for CCUS. enhance the links between university and industry, and develop all this CPD and micro-credential environment. Next slide. I think that was the final one. Yeah. Thank you so much. Uh, Happy to answer any questions. And yeah, if you want to send me an email, ask me about anything, please feel free to do it. Thank you.
Okay, thank you very much, Dr. Michaelias. Can we give a round of applause for Dr. Stefan Michaelis? And one thing that I connected regarding this presentation to my field, which is in public administration, by this presentation, we can link to the ESG policies or environmental, social, and governance policies in the future that it's really can apply for carbon taxes management on the government, and also can decrease the lowest cost production on the manufacturing industries. And right now we're going to the discussion session. We right now open question and answer sessions, and everyone, if you have questions, please raise your hand, and we just open for 2 questions. And I invite Professor Mariam on the stage to join with us. Okay. Okay, ladies and gentlemen, please raise hand if you have questions. Okay, please. Can you help me to, okay, we have 2 questions. Yes. After the guy with the word, but yes. Please introduce yourself and name your institutions, where you come from, and which faculty or in which university that you come from.
Okay, thanks for the time.
Okay, thank you.
My name is Adrian Bagusya Putra. I'm from Electrical Engineering, Vocational UNESA. I would like to direct this question to Dr. Stravos. Considering Indonesia is energy system, what barrier may limit the implementation of waste to hydrogen plants integrated with CCUS? Thank you.
Okay, for Dr. Stravos, the question is, consider Indonesian energy systems, what barriers might limit the implementation of waste to hydrogen plants integrated with CCUS?
Yeah, I guess there are many barriers. First of all, can be technical barriers, because we have to bring many different technologies to work together. As I showcased also in the presentation, policy, okay, policy makers need to be convinced that Indonesia needs hydrogen and support it through subsidies. But at some point, the whole hydrogen sector needs to be self-sustained and attract investors. This can be always difficult in anywhere in the world, basically. And you also need skilled personnel. All right. I'm aware that we have great universities, but always, we have to improve our curriculum also as academics. This is something that I mentioned also that we try to do also here in Hull. We have to be aligned with the industrial needs, with the societal needs. All right. We need to have skilled personnel, skilled graduates, but also skilled operators. Sometimes, in terms of providing skill, especially to operators, demand can be higher than the supply. So there might be demand all over the world about producing, for example, hydrogen, but the technology providers might not be able to meet this demand, to scale up so fast as the demand. So there might be, some shortage of supply of knowledge exchange. But all, yeah, as I said, there can be many that event. This is one of the main challenges of decarbonization, and not only hydrogen is a supply chain issue. It's not just a sole technology issue. I hope that answers your question.
Okay. Okay, sudah terjawab? Yes, answer? Okay, if yes, we're going to the second questions. Please, yes, madam.
Thank you for insightful presentation. My name is Mujira Hayu from SMK Gema 45 Surabaya. I would like to ask, how is your method applies innovation, empowered, sustainable intelligence can meaningfully contribute to more resilient, equitable, and future-oriented society? Thank you.
Okay, okay. So the question is regarding about the tribology, how this tribology is approaches on country like Indonesia and the next perspective to those Southeast Asia.
Thank you. Sorry, I didn't get your question just now. Well, actually, tribology applies almost in our daily lives. So in context of Indonesia, we can actually, like us in Malaysia, we already have the society where we actually organize in the year 2007 until today. At first, our intention is just for awareness, right? But now it has been evolved, and somehow we have this tribology meet up almost every year. With all the universities in Malaysia. So I think it will be great if Indonesia can do the same thing. Currently, I have collaboration with other universities like UI and also UNM, Simalang. So we have done a bit of research that is tribological related. So I guess I can do the same with UNESA. And I think when it comes to tribology, of course, our main intention is to try to minimize that friction and wear problem so that we can, I would say, improve or maximize the energy efficiency. Yeah, so that's the target. Yeah, we try to minimize the carbon footprint. Thank you.
Okay, thank you very much. Okay, Professor and Dr. Strevas, this session is going to end. I will short wrap that. One thing that I can wrap from our session is that sustainable approaches can boost economic or GDPs. As long as we cannot do this alone, we need to something integrate interdisciplinary things to make our research or our plan is possible and well implemented to our society. Okay, ladies and gentlemen, this is the end for the first keynote speaker sessions, and I would like to send this stage to our Master of Ceremony. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you
Please
for
get
having
an applause to us.
Thank you.
Check. Thank you very much. Mr. Andra Pratama Julianto, would like to, our speakers and the moderator remain on stage as we are going to invite the Dean of Faculty of Vocational Programs, Bapak Dr. Suprapto, to present token of appreciation to our speaker. The token of appreciation is presented by the Dean of Faculty of Vocational Programs in appreciation of the time of our keynote speakers, their visions, their contributions. We present this token of gratitude to our distinguished speakers. Once again, thank you. A big applause to our speakers. Thank you. Thank you very much. Once again, we thank you very much to our keynote speakers and also the Dean of Faculty Vocational Programs who are joining us this morning. Ladies and gentlemen, we will now take a short coffee break before we proceed to the second keynote sessions with our speakers from Taiwan and also Australia. So please resume at 10 a.m. The refreshments are served at the back part of the room. I would like to encourage you to be on time and take your refreshments on the table while we are waiting for the second keynote sessions. Thank you very much. Kepada Ibu Bapak sekalian, coffee break telah disediakan di meja belakang. Kita akan memulai sesi keynote yang kedua pada pukul 10:10. Ibu Bapak dapat mengambil makanan dan menikmatinya selagi menunggu di meja masing-masing. Ladies and gentlemen, please, we have a take a short coffee break. Refreshments are served at the back part of the rooms. Please resume our agenda at 10 a.m. as we continue to the next keynote sessions with our speakers from Taiwan and Australia. Thank you very much. Ladies and gentlemen, welcome back, and we hope you enjoyed the coffee break. We are delighted to see you again in the hall for the next keynote season. Ladies and gentlemen, this morning we've heard inspiring perspectives from two speakers from Malaysia and also from the UK. And for the next keynote sessions, we'll have still three speakers. We have from Taiwan, Australia, and also the Director of Student Affairs, Ministry of Education of Indonesia. Before we proceed to the keynote session, ladies and gentlemen, we encourage everyone to remain actively engaged during the keynote session. And also on behalf of the organizing committee, we would like to extend our gratitude to our partners and sponsors to support this conference. We thank you very much to Kawan Lama and also Latvia, Cherry Mentari, Korporanesa, PT Enamku Buku Indonesia, Bank BJB, Bank Mandiri, Sepatu Awake Footwear, Tola Angin, and Sevima. Once again, thank you very much to our partners and also collaborators to make this conference happen. Ladies and gentlemen, we proceed to the second keynote session. Without further ado, let's introduce our speaker for this session. The first is Professor Dr. Stephen Billett of Griffith University, Australia. And also the second speaker is Professor Huang from National Yunlin University of Science and Technology, Taiwan. This session will be moderated by our colleague, Ms. Indah Wulandari, our colleague from Media Production Program of Vocational Program. Please join me in welcoming our moderator and also speakers on stage for the second keynote session.
Okay, good morning, distinguished guests, respected professors, and researchers, and ladies and gentlemen. And I hope you enjoy the refreshing coffee break. And I would prefer say hello first. Hello, Prof. Billett. And it's my great pleasure to introduce our next keynote speakers on Third International Conference of Aligning Sustainability with Vocational Innovations. And it's my great pleasure to introduce our next keynote speakers, Professor Dr. Stephen Billett from Griffith University, Australia. And Professor Billett is an internationally recognized scholar in adult and vocational education. His research has made significant contributions to workplace learning, vocational education, occupational development, and practice-based learning. Throughout his distinguished academic career, he has published numerous books, journals, and articles, contribute to UNESCO, and served as the founding editor-in-chief of Vocation and Learning. In today's keynote speaker, Professor Billett will share his perspective of strengthening the role and capacity of vocational education to address current and future challenges. Okay, before Prof. Billett to presentation, so please give applause to Prof. Billett. And time is yours.
Good morning. Hope everybody's well. And I hope the slides come up. Coming up now, the slides. One important factor is that I'm actually a graduate of vocational education. So after schooling, I did vocational education and later on moved into fields of working in vocational education myself, and then later on transferring to government after that to university to become a researcher. Focused very much on how people develop their occupational skills and then continue to develop them across working lives. Okay, so this is the presentation, and I hope the click, well, yes, it's working. So what I want to argue in this short session is as follows, that there's now changing circumstances which is demanding that we rethink and reimagine the goals and processes of vocational education. And often the purposes of vocational education are very much directed towards the broad needs of industry, and these are often organized through national curricula focused on industry needs. Very much a specific focus on through national occupational standards. But things are changing, and so we need to perhaps reconsider and reevaluate some of this. And that is that what I'm going to suggest is based upon a body of research I've been doing for the last 3 decades, that's 30 years, some ways in which there are 5 now key purposes for vocational education. And these are as follows. And I'll refer to those very shortly. And importantly, to advance these particular purposes, the emphasis here will be on being more than simply reactive to these goals, but actually vocational education having leadership and being involved in innovation. So this talk really builds upon what was being presented in the last 2 sessions, which is that how do we enact these ideas through vocational education or tertiary education. And importantly here, more than just about individual learning, the focus needs to be on how that vocational education can assist enterprises become more innovative and respond to the constant challenges which all nation states are confronting at the moment. Okay, and I'm going to discuss this in 2 parts. Firstly, talk about the purposes of vocational education, and then the importance of doing things at a local level, actually having the capacities to enact this at a local level, here in Surabaya, for instance. So, if we think about vocational education as a sector, the purposes of vocational education, the first 2 perhaps were advanced by John Dewey, who was an American philosopher. And he suggested, first of all, that the first goal for vocational education was for individuals to find an occupation to which they were suited. And Dewey argued that if people didn't find themselves in their occupation, they're wasting their lives, that they were engaging in what he referred to as uncongenial calling. The second purpose that Dewey proposed was preparing people for the occupation to which young people, or not so young people, are suited. Had Dewey lived a longer life, he lived a long life, I should add, he would have probably said that the third purpose is about continuing education and training. And this is because the kind of skills and capacities that people learn in their initial occupational preparation, in vocational education or university, will not sustain them for a life of work, because the requirements for occupations constantly changing, the requirements for employability are constantly changing. And vocational education has a particular problem across the world, both in countries with developed economies and countries with developing economies. And that is, it is seen as being low status and low standing. And consequently, a key part of vocational education is to encourage people to engage with it. But as you all know, we're now living in times of constant change. And so the 5th purpose I'll be talking about is how we can initiate and enact innovations through vocational education, which is consistent with the theme of the conference. Okay, so noteworthy here is that without an adequate interest and engagement by a sufficient number of students, for instance, young people, VET's ability to realize its important social and economic goals are unlikely to be realized. And that personal and institutional investment will be wasted, institutions being the amount of effort spent by government on education institutions, workplaces, etc., if young people fail to find their future occupations through VET. And then occupational preparation needs to prepare people who have the ability to adapt what they know, can do, and value, because the requirements for work are constantly changing. And finally, CET provisions, continuing education and training provisions, need to be offered in ways that meet the needs of working age adults, and also undertaken in ways that generate innovations in work settings. So they're the key points I want to make. Now these ideas are based upon 3 decades of research. I'll briefly go through this research on what actually constitutes the demand side of vocational education, the importance of social partnerships, of engaging with enterprises and public and private sector enterprises as part of the vocational education provision and higher education provision these days, and also the importance of workplace learning experiences and the particular kinds of continuing education and training models that are going to be helpful for working age adults, and trying to improve the status and standing of vocational education, and then also the integration of experiences in work settings with what happens in educational institutions, and then how innovations can be generated in work settings, and then engaging people who are often marginal in our communities to engage in vocational education. And as you'll see across this table, this research has been undertaken in Australia. Quite a bit of it's been undertaken in Singapore, but also has been involved in countries in the Middle East as well. Okay, so I'll go through each of these 5 purposes. The first one then is engaging young people and their parents in viewing vocational education as a worthwhile sector. And this is important because without it being seen to be a worthwhile occupation, leading to worthwhile occupations, it's difficult to realize the kind of national and social economic goals that are being required. And you'll remember the last speaker actually referred to this. He referred to the importance of generating the workforce that's able to carry out those innovations he was referring to. And what's happening in the current era of high aspiration, vocational education is often seen as being a choice only for those that have no other option. And so government and education systems often view vocational education as a low priority, and scant, and well, that scant means limited and often ad hoc funding. And so we're not able to attract the kinds and numbers and caliber of young people into vocational education that we need. So engaging young people, their parents and caregivers in understanding the importance of vocational education is important. Hence, we want to see it as being an important sector. I'm not sure what happened in Indonesia, but in February 2020, at the commencement of the COVID pandemic, what we had in Australia was, the basic face mask, even more basic than the one that's being worn over here. For a population of 23 million people, we had one small factory producing the face masks. It had 4 machines, and one of them was broken. And guess where the fabric came from? You can imagine. and we were producing no PPE in Australia for all of the healthcare workers. And this is really now getting people to think how important it is for nation states to be more self-sufficient and self-reliant with the kind of things you need to maintain, for instance, your sovereignty in terms of not having to rely upon other countries. And at the heart of that are the kind of skills that come from vocational education provisions. So in this study here, this was a study about how we would engage young people who are highly marginalized. In this case, it's Indigenous people, young Aboriginal people. And what we knew from an earlier study is that they wanted specific things from vocational education. So we asked them, what did they want from it? And these are some of the things that they said they wanted. They wanted engaging work conditions, work that was stable and provided them continuous employment. They wanted opportunities, good pay, of course, and they wanted situations where they could make friends. They also wanted work that was inspiring, caring, and would develop knowledge that could assist them help their families and communities. And they could learn new skills. And they wanted support and opportunities that would allow them to understand that. And that included having opportunities to see which occupations they were suited to. So this was very much focused on allied health, preparing these young people to work in the allied health sector. And they also wanted education that was engaging, education that actually they found would develop the kind of skills, the kind of outcomes that they could do something with, could actually apply outside of the educational provision. So these are the sorts of things. But when you look at that list, what you see is those things need to be provided at the local level. They're the kind of experiences that have to happen at the local level. They can't necessarily be mandated centrally. Now, the second one was, how do we assist young people identify suitable occupations? And the idea here is that to assist them, try and identify what kind of occupations they're suited to and have interest in. As a matter of interest, in the Australian vocational education system, over 50% of our apprentices do not complete. They fail. They don't complete the program. And then largely the areas that are dominated by young females, such as hairdressing, they dutifully complete their apprenticeship and then leave the occupation in very large numbers. So there's something wrong here with how we're making young people aware of the kind of occupations that they might be suited to. So young people making poor decisions can lead to very low retention, as I've mentioned, in occupations, and it can lead to very long and circuitous pathways for them to find the occupation to which they're suited. And therefore, the risk then is that young people will end up in working life that they don't find interest in. And if that's the case, they're unlikely to want to, invest effort in developing further their capacities in those occupations if they're not interested in them. Makes sense, doesn't it? So we then know that this has got big implications, like countries like Germany, for instance, which has a long tradition of developing skills. They're now struggling to get young people to become apprentices in many of the large companies. And my colleague, Thomas Diesinger, refers to large corporations in Germany having competitions to try and get the best apprentices because there's a shortage of good apprentices, good young people wanting to do that work. And in the United Kingdom, Alison Wolf is concerned that there's not enough young people engaged in learning technical work, engineering work, etc., and that this is very important for the British economy in the future. So, but young people might need guidance and assistance to identify the occupations they're suited to and are aligned with their interests. So what we found was that through a project where we engaged and asked young people about the processes how they made their decisions, we found a couple of things which were interesting. One was that they needed information at the local level. More than just getting brochures, websites, talking about occupations, what they wanted was somebody to engage with them to actually align their skills and their interests with specific occupations. Interestingly, we also found there was a difference between the decision-making that young people make in cities and in rural and regional communities. And in those communities, it seems that the young people were more aware of a range of occupations, and that might be because they were more visible than when they're living in a big city. So here, what was interesting was to find that it's important to identify the interests and align them with the particular occupations, and that needed to be guided at the local level by somebody who can identify their capacities, who is aware of their capacities and interests, and then assist them identify the occupations to which they're suited. Now, the third focus is the traditional one of vocational education, and that is preparing people for the occupation. And my understanding is that you've got the Skills Olympics happening here at this point in time, and that's an example of that, of the programs which we prepare people for occupation. Yet increasingly, we're being asked to try and prepare graduates to be job ready. And there's a big difference between preparing people for an occupation and preparing them for a specific job, not the least because we don't know which job they will actually have once they leave. And there's different objectives, educational processes for preparing people for occupations than for specific jobs. And this extends then to things like these general skills associated with 21st century skills, problem solving, critical thinking, etc., etc. And the point is that much of this needs to be developed in ways that are relevant to practice. And because there is a need for continual change, we have to prepare graduates for those changes. They have to be adaptable. Now, the teaching I did in vocational education was in the area of clothing design. Believe it or not, earlier in my career, I used to be a clothing designer. But that's a technical job about how you design and manufacture garments. But in vocational education for that field, you can't just teach students about the current garments, because guess what? By the time they graduate, what's happened? Those garments are in the second-hand shops, aren't they? So you have to prepare the students to be able to, the future. You have to give them principles and practices that will allow them to adapt and make garments for the future. Who knows what styles will be they'll have to manufacture. So developing these adaptability seems to be a very important goal, and that is because vocational education graduates will adapt their skills because occupational requirements are changing, but also the needs of specific enterprises constantly change as they respond to the needs for the provision of goods and services that are requested of them. So workplace experiences, I think, are an important part of vocational education. It's interesting, in Singapore, where I do a lot of work, up until recently, the idea that students would have any work experience was seen to be wrong. The idea was that students in school and in tertiary education had to concentrate on their studies. Whereas in a country like Australia, most high school students have extensive work experience because they have paid part-time work. But recently, Singapore has changed its view, and now all of the students in the polytechnic courses in their third year do an entire semester of work placements because the realization of the importance of work experiences. And what we know is that workplace experiences can provide some of the following. Firstly, the kind of authentic activities and interactions associated with the occupation. They're actually engaged in the thinking and acting that they're trying to learn about. Also, that what we know is that when you engage in practice in settings, there are a series of learning outcomes that are derived from having those experiences in that settings, which help understand and retain the knowledge about the particular domain of activity, in this case, the occupation. We also know that when you engage somebody in an activity in work settings, it is highly purposive. That is, it is directed towards achieving outcomes. And if those outcomes aren't achieved, well, there can be problems. So people become focused because you actually have to achieve in a way that perhaps you don't in educational settings. And then the other thing which is really important is that you engage in a lot of practice, repetition to develop the skills. Now, when I was teaching in vocational education, if I was teaching my students about making this collar here, or this pocket, or this front placket here, the students would just do one of them. They'd put them in a little plastic envelope. But what they needed really to do was do 20 or 30 of these, to do 20 or 30 of putting the pocket on, do 20 or 30 of putting the placket down the front, not to mention this here. Because by doing the practice, you develop the skills, you develop the ability then to actually reproduce. You don't do that by doing something just once. It's like lots of things. You need to rehearse and have practice. And that can come through workplace settings in a way that can't come through educational provisions. And also, when you engage in work activities, you often take things from one point to another point, and you learn the value then of what you do here and how that relates to something else. So if you're caring for a patient in a hospital, for instance, if you're learning to care for patients, by engaging in the activities, you can monitor the patient and you can see whether the kind of treatments they're being offered actually leads to the outcomes that is intended. You engage in this and understand then a series of interrelated factors that's so important in depth of understanding. And as I said, you're able to monitor the progress and outcome of the work you're engaged with. So these are all important aspects of learning through work. It has its weaknesses and limitations, and therefore it needs to be guided and supported. And in this, there's a bulletin here, and I've had this bulletin translated into Indonesian, and at the end I'll show you QR codes, how you can get that. But to improve learning in the work settings, it seems that from the work I've been doing is that there's 3 sets of considerations. The first one
Excuse me,
to the
Prof. Bidet, reminding you have for 5 more minutes. I'm sorry.
No, I think more than 5 minutes.
Okay. Sorry.
So here there is curriculum practices which are associated with how you progress along a set of activities. And then there's pedagogic practices, the kind of ways that you actually enrich the experience. And they're very different strategies than those that are enacted in classrooms. And then there's the personal practices of how the person comes to engage, which is so important. In addition, and also there's this idea of how do we integrate the experiences that students have in the work setting with the educational setting. And so there's a set of guidelines here, and again, this has been translated into Indonesian for you. And this is about 2 concepts. The first one is work-integrated education, how we provide experiences, education, but also how we reconcile the learning that students do, work-integrated learning. And in this handout, and again, it's been translated for you, what you will see is that there is considerations about students' readiness to engage in work settings and how this can be best supported by educators. And this emphasizes the importance of perhaps the most important concept of curriculum, and that's the experience curriculum, how students come to learn from it. Now, I'm being hurried along here, so I'll try, but In addition, there's processes for continuing education and training. And excuse me, it's important to remember that when you're dealing with working age adults, that it's a different situation than when you're dealing with young people. Because working age adults often have a range of commitments. They have a work commitment, family commitment, community commitment, and as well as their further education. So we have to find provisions then that can fit around that. And so we need this, a range of different kind of experiences, excuse me. And then from this study, which was conducted in Singapore, as I said, we need to accommodate those three forms of other commitments that working age adults have. And what suggested is that, for instance, a combination of online and face-to-face activities are likely to be important, and that within the work settings we need to sort of organize experiences to maximize the learning, and one of those is what is referred to as pedagogically rich activities, because there's particular activities in work settings which are inherently rich for learning, and we need to identify those and utilize those fully. The fifth point, which I'll come to and then kind of finish then, but is that the importance of workplace innovations, of vocational education being directed towards bringing about change in workplaces and workers being engaged in innovation. And the idea here is that when somebody innovates, guess what? They're learning. Because when you do something new, guess what? It's called learning. And when you encourage people in work settings to innovate, to respond to problems they're confronting, A, they learn, and secondly, the workplace benefits from those experiences. So by engaging workers in innovations in work settings, you're achieving two outcomes: continuing education and training on the one hand, and the workplace being able to respond to new challenges. Imagine the kind of changes which are occurring now with artificial intelligence and how we need to organize all of that and respond to it. And so this innovations is central to meeting societies or communities' social and economic responses. Consequently then, VET is helpful then for achieving those outcomes. Now in that work in Singapore, the research bulletin's over here, and again I've translated that into Indonesian for you. The project there found that initiation of innovations in Singaporean small to medium-sized enterprises was based very much on workers themselves and support they got from those workplaces. And that included support that came from supervisors, and that engaging in innovations was premised upon the workers and what they did. And it was the workplace that largely determined the degree by which rewards were initiated and also opportunities to engage in innovation. So much of this then is based around workplace culture. And finally, I'll just make this final point, that all of this is very much premised upon things happening at the local level. Whether we're talking about all of the things I've been talking about here, whether it's the standing of vocational education, meeting the needs of students and local communities, how disadvantaged communities can best engage, how social partnerships can best be enacted, and meeting employers' needs. All of this is can best be understood at the local level. And to achieve this outcome, it would seem that there's three key qualities that's required. The first one is at the local level to have the social infrastructure. That is the kind of patterns and pathways between educational institutions and workplaces, for instance. And also you've got to have the administrative structure that can support provisions at the local level, and also the educational infrastructure to achieve that outcomes. And that is the competence of the teachers and the ability to respond at a local level. And just to finish, that it's all about localized engagement, but it's also about engaging the learners. Because if students, when I was teaching the fashion courses, I didn't have any problems with student discipline because the students found it so interesting, they wanted to be there and they want to engage. So how can we make our courses engaging for young people so they want to be there, they want to be engaged in the thinking and acting? That's a challenge for us as educators. And this is just to say that this means also that educators need to be able to engage, broadly and make their curricula and pedagogic practices interesting and relevant to the kind of learning outcomes that students want. So thanks for that. Now, I'll just say that at the end here, what I've done is, and I'll just go on, is that here, and now QR codes, what I've got there is those three bulletins, the one on learning through work, the one on integrating work and experiences within the academy, and also on continuing education and training from the Singapore study. They're translated into Indonesian, so you can hopefully engage with those. And also there's an Indonesian copy of the PowerPoint I presented here that's available for you, and I think the organizers will be circulating that. So thank you very much for your time. Thank you.
Thank you. Thank you, Prof. Billet, for your insightful presentations. And we truly appreciate your valuable perspective on vocational education and building local capacity for future challenges. So we will now continue our next keynote speakers. And it's now, you're welcome to return your seat. And it's now my pleasure to introduce our next keynote speaker, Professor Sing Hui Wang, who is joining us online from Taiwan.
Yes. Okay,
So we're
thanks
still
for
waiting
your...
to connect with Prof. Wang.
Yes, hello, I'm Huang. And my PowerPoint can be showed on the screen.
Yeah. Hello.
Okay.
Good morning, Prof. Wang. Sorry if any mistake when I'm mentioning your name.
That's right. That's right.
Okay. Yeah, Professor Huang, Vice President of National University of Science and Technology, UNTEC, Taiwan. And Professor Huang is a distinguished scholar in design, cultural and creative industry, community development, and social innovation. Throughout his academic career, he has held several leadership positions at UNTEC and has dedicated of his research to cultural sustainability and applied design. Today, he will share how traditional weaving can become driving force for cultural preservation, community empowerment, and sustainability development. And ladies and gentlemen, please join me in welcoming Professor Huang.
Thank you. I'm Huang. And today I will introduce a special village, a special settlement. It's an indigenous settlement. And I will talk about the concept of sustainable Satoyama. Many people may know the keyword Satoyama. Satoyama actually is Japanese language, Japanese words. It means that if people who live in the mountain, then they have to take care of the mountain, including the plains and the landscape, and also the ecology. So I will introduce this small case in middle of Taiwan, and I have 4 parts to introduce. The first one is the background of this village, of this settlement, and the second one is in that settlement there is a weaver's home. It's a kind of workshop for weaving. And the third one is I will discuss about the advantages, limitations, and the adjustment of promoting this kind of sustainable weaving business. And then finally the conclusion. So firstly, I will introduce the location. So please see this map, then you can see we are in in the middle of Taiwan. And the small settlement is named Zhongyuan. So from this picture, we can see there is a Beigang River. It's a river, so the settlement near the river. But in the left side, in the right side, there is the mountains about 1,000 meters high. So this is kind of a Satoyama landscape. Then in this place, we can see the residents living in Zhongyuan settlement are the indigenous people of Sidik. The population is about 700 persons, and agriculture is the main work for them. The whole population of Sidik is about 12,000, but in this small settlement, there are only 700 persons. When we go into this small settlement, then we can see some painting on the wall, just like this. This is the main street of the settlement, and there are about 10 paintings on the walls. For example, this one means that we can see the owls. Then the people say that when an owl hoots, it means someone in that household is pregnant. And because of the different sound of their hoot, then we can know that the woman maybe will give birth of a boy or a daughter. And only women who have mastered the skill of weaving are qualified to receive a facial tattoo. So please see this painting. You can see that this is a small one. So this is the way they weave, and if the women who are skillful in weaving, then she is qualified to have the facial tattoo, just like this one. Next page, please. I'm talking about the left one, the lower left one is about the owl, and the right one about the tattoo of the weaver. The next page, please. So Sitik weaving is a kind of a well-known craft in Taiwan. In the past, Sitik women wove clothes for their families to make clothes, blankets, or wrapping clothes. They believe in ancestral precepts. They call it Gaia. Gaia is kind of concept that the ancestors, what ancestors say. So Gaia said that women must know how to weave to reunite with their ancestors through the bridge. The bridge is a kind of a rainbow bridge. You can see the rainbow bridge. So if the women are very skillful in weaving, then he can have a facial tattoo. And also, after they die, they can go on the bridge, the rainbow bridge, to meet with their ancestors. Next page, please. Okay, so they use a kind of plant to do the weaving. Before doing the weaving, they have to make the thread. So they use this kind of plant is remi. This is remi, and the tribes use remi to make thread for weaving. And they planting and processing remi is usually a woman's job. So women have to plant the remi and then use it. Such small landscape of remi fields usually around the tribal house. So they plant the remi just near their house. then this become a kind of a small landscape. Next page, please. And how to do the thread and how to do the weaving? There are many steps. The first one is plant rami, and the second one is scraping the rami by bamboo, and washing in the river and drying them, and then connecting the thread together. Then the sixth step is spinning. So they use this kind of rami to make threads. Then using this kind of thread, they can make bags or cloth. Next page, please. So the seventh step is boiling. All of the threads will be put into there, and then boil them. After that, they can do the dyeing and finally make the thread. So when they got the thread, then they can weave the clothes in a kind of a backstrap machine. Next page, please. Okay. The traditional weaving is closely related to the nature because they use the rami and the other plants. For example, if they want some a brown color, they will use another plant to do the dyeing. So as you can see, all weaving materials are taken from the nature. Okay, next page, please. And after they weave the clothes, and they will be used in many places. So the weaving skill, the weaving itself, is not only a kind of clothes, but also relate to social interaction. For example, the people who are going to get married, then her mother will weave a lot of clothes as a dowry. Then she can when she married, then she can use the clothes in their home. But also it's a kind of thanks gift. So it's a kind of dowry and also it's kind of gift. So we can see the background of the whole weaving skills, the weaving. The traditional weaving presents a completed cultural ecology because it includes Gaia, natural knowledge or technical learning, indigenous languages, personal practice and social interaction, and generational linkage. So the traditional weaving presents a completed cultural ecology. This is a very special one. Next page, please. So when we look back to the history of the weaving, before 1960s, every woman can weave. They have to plant the ramier by themselves, and weaving is closely related to the tribal environment because they just plant the rami near their house. But in the 1960s to 1980s, clothes are purchased instead of weaving. So the tribe women gradually abandoned the weaving. But still, a small number of weavers, they keep on weaving clothes, and the clothes are sold in a tourist area. And in 1980s to 2000, tourist areas are replaced by factory-made clothes, so they are facing the crisis of a skill gap. Because the young women, they will not learn the weaving right now. Next page, please. So I and my students, we try to do the investigation, do the field survey to understand what their culture is and how the technique is. So you can see the university students try the Siddiq tribes traditional wearing. These are my students. Next page, please. These are my students. So they get into the village and also do a field survey, especially for the weaving. Okay, next page, please. So we went into the village and have do this investigation for many times. Every time we takes 2 days over there, and finally we have the discussion about the investigation, about the field survey, and finally we will present our finding and for the village persons. This is part of the document that we made. For example, the story about the weavers of 3 generations that had been interviewed by Intech students. Next page, please. Yes, this is the place that we present our result of the investigation. Next page, please. So this is what we made about the story of 3 generations of weavers. Next page, please. And the second part, in this settlement, there is a special store or a special workshop. It's called the Weaver's Home. The Weaver's Home is established in 2016. This is the only group and the open space in this settlement that develops with weaving, taking into account both cultural preservation and the commercial mechanism. Right now, they only have 5 employees, but it plays an important role for the whole settlement. Next page, please. Weavers' homes have many kinds of actions. It includes woven and sewn into bags for sale, and make packaging travel. In other words, it's a kind of tourism. Then they also apply for government subsidies to support their learning and survey of weaving. So in this page, we can see some bags. They are designed by our students and the Weaver's Home. Next page, please. When we contact with them many times, and we found that it's very interesting to do the thread. Especially when we cut down the rami and use the bamboo to find out the basic of the threads. Then it's a very interesting one. So we suggest them to develop the experience of thread making by rami. So after that, they also go out for weaving teaching and extend the experience of scraping rami for tourists. So the Remy field is replanted next to their home. And this is this is another theme. It's not related to the weaving, but about the hunting. Here is the hunter Buhu, Mr. Buhu. Cooperating with UNTech since 2020 till now, there are about 7 to 10 workshops have been held. Then our team helped them to record and organize their local knowledge. And we care about how tribes can use the information that we collected. For example, the ethnic plant surveys, we find many kind of guava that hunters were used. So finally, we collected about 60 kind of plants that hunters were used. The right side of the pictures are some special trees that hunters will use. For example, the ethnic plant survey, there's kind of tree that can, the kind of tree is very salty. So the leaves are very salty. So the indigenous people will use this kind of leaves as salt. Okay, next page, please. The third part is I would like to discuss the advantages and the limitation and the adjustments of promoting sustainable weaving. We find that the natural environment can still provide the weaving material which needed by weavers, and they still have many weavers in the tribe, and the skill teaching courses is continuing in the tribe. And the weaver's home plays an important role as promoter of traditional weaving. The indigenous characteristics attract tourists to learn, experience, and consume, and this help the economy of the settlement. Next page, please. So, but there are some limitations. Their limitations are a low speed of hand weaving, because the weaving is by hand, so the speed is very low, and the high labor cost. So they also want to protect the traditional culture. So it is difficult to operate with a pure profit model. So innovative development of weaving products, transforming traditional weaving technology into experience economy, maybe is a good way for them. That's what they are doing. And they also have to apply for government subsidies based on the cultural value of traditional weaving. So next page, please. So from this diagram, we can see that the weaver's home, their products and their economy since 2016, and basically they have the knowledge of weaving, and they also develop a kind of so-called solidarity economy. And because of they use very natural materials, so it fits the concept of Satoyama. Satoyama means social, ecological, productive landscapes. And my university, UNTEC. UNTEC will help to collect the community culture and the historical stories, and we will arrange the hunting and ethnic friend surveys, and we also design some display and products for them. Next page, please. But according to our analysis, their income can be separated into three parts. The first part is the blue one. It's a business guided tour and weaving experience teaching. The second is about 19%, and the second part is the red one is business. In other words, they will sell their weaving products. The income is about 13%, and the other one, about 68% of the income is still have to rely on government subsidies. Next page, please. So we found that this settlement has more weavers than other tribes. So it has the opportunity to develop a kind of weavers' village. And right now we have the common sense. We have the common will that maybe we UNTEC and the settlement people can make effort to reach the idea of weavers' village. And those who can make someone also can not only the weaving but the tours of the weaving. The people, the local people can make the weaving tours, and the surrounding environment has the biodiversity, and the weaving operation continue to can keep on expanding, so it has a sustainable advantage. And the local plant, Remy, as a small landscape gradually reappeared in this settlement. But the function changed from Remy used in life to cultural experience Remy. And
sorry,
also we
Professor
can
Wang, gentle reminding you have 5 more
okay, I'm
minutes
going
in
to
reminding. Thank you.
Okay. Okay, so in this map, we can see that there are at least 6 persons who can do the weaving. Next page, please. So this is a basic a concept that the village is, the settlement is supported by 2 kinds of things. The left one is revitalization of weaving, and the right side is tribal guidance or tribal tourism. So because they have these 2 kinds of umbrella, a protective umbrella, so their culture can be sustainable, can keep on their culture inherited. So the final conclusion, there are 3 conclusions that because of the competition from modern apparel, traditional Sitic weaving has moved beyond the commercial logic of capital market competition. Instead, they forged an alternative path of accommodation and adaptation through concepts such as tribal culture, learning, cultural services, cultural industries, cultural resilience, and the Satoyama initiative. Weaving revitalization, tribal culture guided tourism, and the Satoyama experience have become vital pillars in helping the tribe achieve autonomy. So this is what I wanted to, how I want to introduce the special settlement in middle of Taiwan. Thanks for your listening.
Thank you, Prof. Wang, and give applause to Prof. Wang. So now we will now move to our panel discussion, and I would like to invite Prof. Billet to join us to discussion panel. And for audience, if you have a question, please raise your hand. And gentle reminder that introduce yourself. Yeah, okay. Oh, we have a 3, 4. Okay, so which one? Okay, from the right side. And indicate which speaker, which speaker your question addressed to.
Okay, my question is for Mr. Professor Stephen Billet. I'm sorry if. Okay. Thank you for the time. My name is Chandana. I would like asking the questions about vocational education. Well, in Indonesia, vocational education has its own curriculum, while the world of works also has its own qualifications. The problem is how we, as a teachers, reconcile these two differences. While we must meet curriculum target, but we are also encouraged to meet workplace qualifications. We already know that Australian have a good, I mean like, good educational program, and it's uh, and it's support from the government. But in Indonesia, we have a differences. So maybe professor can give us advice to help us as a teachers.
Sorry, I'm not sure I caught all of the questions. So it's about professional development of teachers?
Yes. This is
And it's the way that that can happen in work settings?
yes, for the students.
Sorry?
For the students.
For the students?
Yeah.
Yes, okay. So there's different models of the way that students can have work experience, and sometimes it can be the workplace will accept students and they'll be there for some time. Like in Singapore, all of the students will be there for 14 or 16 weeks. Sometimes that's possible, and then the students get engaged in a range of work activities. So there's that kind of model. There's also different other options, and that is, for instance, students observing what happens in workplaces.
Okay, sorry, mister. But in internship moments for the students, they're not 100% get the experience, 100 experience as the worker. They just learn as a theory, but not do it practically when they come into the internship moments. So the internship sometimes just for, I'm sorry, not 100% got the experience as a worker for the student. So it's so hard for us as teacher. I mean like, yes, just like a formality.
Okay, thank you. I think I now understand your question. In the in these material I was presenting about work integrated education, what happens is things have to happen before the students go into the workplace.
We teach them just a theory, as like the curriculum asks for us to teach.
Yeah, but so for instance, theory or ideas is fine, but for instance, if we take nursing as an example, before nursing students go into hospitals, they learn how to take stents, they learn how to do basic dressings, they learn how to perform basic procedures so that when they go into the workplace, they can do some things and they can engage in the work settings. So that's why it's very important before the students go into the workplace, they're provided with some capacities so they can engage and do something productive in the work settings. That plays out in different ways. So sometimes, for instance, if I take the example of student nurses, they have these laboratories where they go and practice doing basic dressings and things like that. And they work on mannequins, dummies, and develop procedures before they go into the work settings. But also, say, for instance, if you're a journalist, if you're doing a journalism course, before you go into work in a journalist workplace, you learn how to write in a way that journalists are required. It's called active prose, rather than the kind of style of writing that's required by the university. So the overall concept is called readiness. And that is the ability of the student to be ready to go in and engage effectively in the work setting. So that's what we need to do to prepare students so that they actually can engage. How that happens, it can happen, for instance, through students having the opportunities to visit workplaces so they understand what happens in a workplace, as well as having the opportunities, for instance, to develop what's called specific procedures, like basic dressings, and so they can go in to the workplace and do something constructive. But when we look at models of how people have learned occupations across human history, we find out the same process has occurred. That when you engage in a workplace as an apprentice, you do tasks which are easy to do, and then you slowly build up your capacities. And that's called a practice curriculum. And so we need to organize experiences for students so that they engage progressively and develop their skills accordingly. Perhaps we will talk later, and I will try and explain. Okay, thank you.
Okay.
Thank you, Prof.
Okay,
Village,
thank
for
you.
your response. Okay, I will go to the next questions. Yeah, please introduce yourself.
Good day, Professor Billet. First of all, I express my gratitude for knowledge that I learned today. Thank you, Mr. Professor Billet. Now, so I was particularly interested in your point about helping young people find career that align with their interests and strengths. In your experience, what can universities do to better prepare and guide students when making this important career choice? However, we often see college students choosing a university just for the sake of social prestige without regard for their actual interests. Once a student has made such a choice, how can the university maximize their potential so that they can be of benefit to those around them? So, like, uh,
You
what-
like long questions?
yes. So the point of my question is how the university do to better uh, help the student to choose their career perfectly and good like that. Like we can see today, many student is just focus on their local social prestige, not for their
Okay.
actual interest.
Okay, so if I understand the question, it's about how students can be informed about the range of career options.
Yes.
Say, for instance, in something like engineering, because there's lots of different forms of engineering or administration or whatever. Well, one of the ways is that you might have students going to different kinds of engineering workplaces or hospitality workplaces or journalist workplaces or administrative workplaces. And when the students have had those experiences, you come back and the students share their experiences with the other students. It's called post-practicum. And so students then can be aware of the different requirements of different forms of work. Could be the way that, different engineering occurs, or different, those examples I was giving. So that's one way that that can happen, where you can draw upon a range of experience of students, and students can share that. But wherever possible, it's very helpful for students to actually understand what the work entails. And so observations, the stories of students who've had those experiences, their teachers, can be very helpful. The reason that's important is that so many people are driven, young people are driven by factors which are not reflecting accurately the work they engage in. So, for instance, one issue is that when young men and women are forming their ideas about occupations, it's often at a time when they're forming their gendered identities as young men or young women, and they're often drawn then to activities which are seen to be what men should do and what women should do. And then they find that when they get engaged in that kind of work, that basis for making decisions hasn't been very helpful. So anything you can do to provide authentic experiences of work settings so that people can make informed decisions. Some of the education models that have existed have been referred to as pre-vocational programs, and that is where students are given tasters of different kinds of occupations, and they then make choices about that. Also, some large organizations, what they do is they have open days, where, like a hospital, where young people can come into the hospital and they can see the range of activities that occur in a hospital, so they can understand the full range of tasks that occur in a hospital, for instance. Because otherwise, young people think of hospitals as doctors and nurses, when there's lots of other things happening in hospitals. So wherever possible, providing access to the experience and then sharing those experiences amongst a student cohort can be helpful.
Okay, my second question is...
Oh, you still have one? We still have one time? Okay, one more question for Prof. Billet. Okay.
Yeah, so like the student is choosing a university by the popular to make the sex social prestige. Oh, this university is popular. I will prefer to in them. Nah, so how the university can do to maximize the potential that the student is not interested in this focus.
Helping sorry, I'm trying to understand your question. So the question is about the decision that students make about course choices, the choices of courses, yeah.
The student is choose the university from the popularity, not their actual interest.
They choose only the popular course, not from really they
right.
want to interest, or they really capable with that some very specific course.
Yes, last trimester I taught a course on Friday evening, and not many students wanted to do it because it was Friday evening, so it can be a problem. I think it's really students trying to work out what they want to do and how best the courses they can undertake achieve what they want to do, if I'm understanding the question. So I mean, I'm not quite sure what you mean by popular courses, the courses that everybody does, but I think clearly is a need to be focused on what you want to achieve from higher education and the kind of courses that you need to do. And of course, early in education, you can go for a range of courses, but then perhaps towards the end, you want to develop some expertise or some focus of your study. So that might direct you towards achieving, undertaking courses in a particular area. Yeah. I'm sorry, I'm just having difficulty hearing and understanding the question. So I do apologize if I'm not responding to the questions.
Okay. Thank you.
Thank you,
Thank you
Professor
very
Billet.
much. Yeah. So we still have time to question. Okay. So this time is up, and thank you for your response. And we all completely decide the first from the lecture side, and then the second one, the question from the student side. So it's completely. So I will back to the MC. Prof. Billet, excuse me, may you remain here because there is token appreciation following the photo session.
Thank you.
I will be around at lunchtime, so we can talk about those questions then. If after, we can talk about them later. Okay. Very happy to talk to you then. Okay. Thank you.
Thank you, Professor Pillay. Once again, please give applause to Professor Pillay. I would like to invite the Vice Dean for Academic Affairs, Mr. Reza Rahmatian, to join the speakers with the moderator on stage to present token of appreciation. Ladies and gentlemen, as we have witnessed how the discussions, I think that the discussion will go on during the lunchtime. It seems so. I really appreciate for your cooperations and also the answers from Professor Pillay for a very nice and fruitful discussion. And also thank you very much to Professor Huang from National Yunlin University of Science and Technology for the fruitful discussion during the second keynote session. Right. Once again, give a big applause to our two keynote speakers for the second keynote session. Ladies and gentlemen, we proceed to the last keynote speaker of our morning sessions. We will listen to the presentation from Bapak Dr. Benny Bandanajaya, Director of Education and Student Affairs, Ministry of Higher Education, Science, Technology of Republic of Indonesia. Please join me in welcoming Bapak Dr. Benny Bandanajaya to start his presentations on the podium.
Okay, thank you for the opportunity. Before I start, maybe I want to greet for Pak Suparto, the Dean of the Vocational Studies, and also Prof. Billet from Australia, Ibu Prof. Mariam from University Kebangsaan Malaysia, and of course, the others keynote speech and all of participant, which is coming here and also in the internet or in the online attendance. Okay, let me introduce myself. My name is Beni Bandana Jaya. I am a director of Student and Learning Affairs from the Ministry of Higher Education, Science and Technology. Today, I will give a keynote speech about the transforming vocational higher education for sustainable impact through innovation, collaboration, and future talent. Okay, next. Next slide, please. Yes, let me start with the word around us that we live in the time of very big change. You know, the digital technology is growing very fast. At the same time, we face a serious environmental challenge, climate change, limited natural resources. There are some disasters around the world, as we know that in Europe last week, last month, there's several disasters, extremes, hot climate, hot temperature. And also we are facing an earthquake, flood, and the others disasters that coming because they are climate change. Yeah. And of course, there are new technology are also changing the way we work. It creates pressure, yeah, but also opportunity. The data now part almost every industry. The needs of the data. We use internet. We use IoT. We need data, big data, and almost every industry using new technology. So what does it mean for us? As one idea, we can say that innovation is no longer measured only by the technology, but it measured by its ability to create a sustainable impact. This is maybe the core or the heart of my talk today. Okay, next. We are lecturers at the university, and the university today play a very important role. They are a bridge, yeah, connecting the theory and the research with the real and practical solution. So we have to connect, yeah, between the theory that we are learning in the campus and we are giving it to the student, to the real case in the environment and in the ecosystem, to give a practical solution. University produce future-ready graduates. They drive research that can be applied in real life, and they help accelerate sustainable development around the world. So we have to give our student the case, the study, the research that came from the real life, so they can learn how to solve the problem. And I think it matches perfectly with the mission of ICASVI, the bridge academic research with the real industrial implementation. And yeah, I think that is exactly what we need more of. Next. Yeah, this is Indonesian vision, yeah, higher education for impact. The Ministry Higher Education, Science and Technology has, what is it, a motto that we should do the research, we should do the learning, we should teach the student how to make an impact what the meaning of impact. Impact means that all what we do has an impact, has a good impact for the society. So the goal is simply to say, but important to achieve, yeah, to move from the just creating knowledge to creating real measurable impact for society. We see that in the system, a foundation, an engine, catalyst, a network, and an output. Yeah, each part work together. You know, the education is the foundation. And then the human capital development, in this case is a student and also our, yeah, as lectures, as the engine. Yeah, we do research and innovation as a catalyst to make it faster. Collaborating is the network. Yeah, and the impact for society is the final output that we hope that we can produce a graduate that meet the national competitiveness needs. Next. Yeah, this is the transforming paradigm of higher education. Let's talk about the big shift happening in education. Yeah, the traditional model, the traditional model, learning focusing on theory. We are in front of the class, the student is sit down, and then they only hear what the teacher said or the lecturer talk. The theory, they write, and then go home. That is a traditional model. Yeah, classes are spread, yeah, from each other. Students stay mostly inside the academic world. Study paths are fixed and linear. Now, in the new vocational, we focus on the outcomes. We call it OBE, outcomes-based education. Not just theory, learning become a project-based. So we can involve the student with some project that we get from the industry. The student get involved and they know about the real problem from the industry or the real world. So they can analyze, so they can learn how to solve the problem and how to connect different subjects together. Students work closely with the industry. Learning path become flexible and lifelong learning. They can learn how to collaborate with the other student, because in this case, the problem-based learning, student will get put together to solve the problem. So they can discuss each other, they can learn to the other student, and they can solve together. They meet them more collaborator, and they can collaborate. And we call it for lifelong learning, because after they graduate, they can do their skill to collaborate, to communicate, to solve the problem with the other case when they face the new or the real problem when they work after graduate. This is the fundamental shift from teaching theory to creating real and sustainable outcomes. Next. Okay, to support this transformation, we need a strong innovation ecosystem. It means that we have to working together. We have to working together. University, industry, government, society. And we call it the quadruple helix, yeah. Quad mean four, yeah. Quad mean four, and helix means some circle. Between university, industry, government, and society. I'm a part of government, and maybe you are all the part of university. Maybe we have to invite the industry here and the society that can discuss about how to do this concept. And there are three important platforms. They are running by the committee of this program. The first is ICASVI 2026. Here we are in the ICASVI, an international hub for academic exchange between different field knowledge from Indonesia and the other country. The second is Olivia. Olivia, after this, maybe tonight, yeah, we are open the Olivia. I will join the opening session. And this is the national stage where students can show the talent and creativity in vocational field. So there is so many competition, I think, for maybe 1 or 3 days. 1 until 3 days, they show the ability for creativity, for the competence, for some competencies competition. And the third is the vocational expo, a place where applied research become a real product, yeah, shown to industry and the public. Yeah, university bring knowledge and talent, industry bring practical application, government brings policy support, and the society brings real needs. So together we can create a real innovation. Okay, next. Now, what skill do our graduates needs for the future? We call this as sustainable intelligence. Sustainable means that it is long-term, sustained, combining smart technology, strong human skills, and care for environment. Yeah, as I said, the first, that today we're facing a climate change, and it threat the people or our life in the future. If we do not care about this, maybe our grandson will suffer because of the climate change. And on the technology side, AI and data analytics, digital literacy, and Internet of Things or IoT. You know, nowadays AI is the most popular tools. I said it is a tools to help us to work. We can work fast. We can work quick with the help of AI. Maybe in the past, when you are preparing a learning media or learning material, you need 1 week. With AI, maybe you only need 1 day. If you can do, and if you know about the AI, how to do it as a tools. On a human side, there is a soft skill that need to be in our student. For example, critical thinking, creativity, entrepreneurship, and also leadership and collaboration. So I think there's all skills that needs by our graduates. Next. Okay. This is the priority sectors for sustainable impact. There are 3 priority sectors for our vocational education. The first is applied physics and smart system. This covers the digital innovation, intelligent design, smart governance, and also digital multimedia. The second is applied electronic advancing manufacturing. This includes resilience design, circular manufacturing, robotic, and sustainable energy. And the third is applied engineering and mobility. This is focused on the eco-friendly infrastructure, intelligent transport, and responsible consumption. And these priorities align directly with the research agenda for the research of science across ASEAN and beyond. So I think we have to take a look what is the priority sectors of our vocational education. But if you have another priorities, it's not. It is also possible, and we can create that all of our program is have an impact, yeah, especially for the society. Next. Okay. There is, yeah, we have to understand. Then there is no institution can do it alone. We also need a global research network. So as we do now, we are doing the global research network. Our strategic initiative include, yeah, joint research, student mobility, international publication, cross-border innovation, and industrial partnership. So, yeah, I discussed with Professor Billet. Indonesia has a limitation about the conversation in English. Maybe I'm also have a limitation about the ability of English. But if you want to do the global research network, if you want to expand your networks with a global society, you have to practice, you have to sharpening your communication skill, especially in English. When you are doing a joint research and you are communicating with the other country, the English is the one of the language that you can use, yeah, to connect with the global society. So of course, I want to thanks to all organizing partner institution. They would honor agreed earlier, and I think all of the international collaboration makes real progress is possible. The Ministry of Higher Education, Science and Technology also provide the research collaboration with university partners in outside of our country, and you can propose for the collaboration, and you can get funding. I think this is a very good opportunity if you want to expand the global network. Next. This is student as an agents of change. We often say that student should be an agent of change. At the center of everything, university is a student. Student is a center. You know, the center is not the lectures. The center is not a rectors or dean or us as a lectures. The center is a student. University without student is not university. Maybe if there are no student in our university, we only as a research centers or another name. And we have to make them as true agents of change. The journey look like this. The first, students start as a learners, building the foundation. They learn in the classroom, they learn in the laboratory, in the workshop, in the internship. Then they are grow into the problem solver. applying the knowledge, and then they are become the innovators.
Excuse me, Bapak Benny, time reminding you
Habis
have
ya?
2 more minutes.
Oke, siap. Innovators and entrepreneurs creating new solution. So this is our goal, how to make a student as an agent of change. Next. 2 slide lagi, Bu. Next. The architect of the future. Okay, let me summarize the transformation into the 3 pillars. The first is learning transformation through adaptive learning, interdisciplinary approach, and industrial engagement. The second is innovation transformation through technology, downstreaming, hilirisasi, applied solution, and social impact. And the third is talent transformation to produce a future-ready graduate with a global competitiveness and strong characters. Together, these 3 pillars form the architecture of the future of our graduates. Next. Last slide. Let me close with this thought. The future belongs not only to those who innovate, but to those who ensure that innovation creates lasting value for society and for the planet. Thank you very much. It is 3 honors to be here in ICASVI 2026. Thank you.
Thank you. Bapak Benny, please sit, have a seat with us because we're going to open the question. Yeah, just one question. But while I gather from the audience thought, I have the one question for you, Pak Benny. You mentioned about the collaborations, this collaboration in Quadrat Helix. So we have to collaborate among the university, society, and industry and government. So in minister perspective, which one is the best challenging from this collaboration?
Yeah, we're facing the challenge to approach the industry. Yeah, as actually vocational education, we have a good platform if we want to learn in Germany, in Switzerland, and in the other countries. They are good in collaboration with the industry. So we are still in build the collaboration with industry. We collaborate with Kadin. Yeah, the government communicate with Kadin to have the university, yeah, to work together, and then we can encourage, yeah, the collaboration. So I think the most challenges, yeah, how to connect the university to the industry.
Yeah. Okay. So I will open just one question because our time is very limited. So yeah, please introduce yourself.
Yes. Let me introduce myself in Rashid, and I'm from civil engineer at State University of Surabaya. In your opinion, what is the biggest challenge teacher or lecturer face when adapting to this rapid technological change? Thank you.
Yes, I think it must that we should adapt with the, what is it, the new technology. Yeah, the new, what is it, yes. Yeah, if we do not following the technology, yeah, maybe the student also will be, what is it, ketinggalan apa? Have a step back, and also they will, yeah, I see that as a teacher or as a lecturers, we have to step forward, one step forward, yeah, after the student, because the student is the learners and we are the teachers. So we have to give them the new technology, the new knowledge. And this why, as the lecturers, we have to learn. We have to not only teach, but we have to also learning about new technology. Yeah, thank you.
To adapt, yeah.
Thank you
Pak
for
Benny.
your answer.
Okay, thank you. So, terima kasih Bapak Benny. So, this discussion remind us that in higher education vocational, it's not just about producing graduates, but it's about creating meaningful and sustainability impact for society. Thank you. And please give the applause to Bapak Benny from the Minister of Indonesia. And we will talk and I will give it back to MC.
Thank you very much, Bapak Benny. Ladies and gentlemen, we would like to present a token of appreciation for our keynote speaker, Bapak Benny Bandanajaya. Please join me in welcoming Bapak Dr. Abdullah Hafiz as Vice Dean for Public and Infrastructure Affairs of Faculty of Vocational Programs. Ladies and gentlemen, once again, we would like to extend our appreciation to the support of the government, that we can see how the advanced development of vocational education, so we can create a more concrete and sustainable impacts to the society. Once again, big applause to our keynote speaker, Bapak Dr. Benny Bandanajaya, for this afternoon. Ladies and gentlemen, as we now conclude the keynote sessions, we will proceed to the lunch. Before we proceed to the lunch sessions, there are some information for you, all the speakers and also the presenters. Once again, on behalf of the organizing committee, I would like to express our appreciation to the speakers and also the participants for all your participations and collaboration to this morning sessions. Please refer to the program book for the parallel session this afternoon. So the parallel sessions will be held in the 16th floor. We are now in this room for parallel A1 to A4, while parallel A5 and A6 will be held on the 17th floor of this building. So once again, please refer to the program book for the parallel sessions. Ladies and gentlemen, enjoy your meals, and we will resume for the parallel sessions at 1 p.m. Thank you very much. Bapak Ibu peserta dan presenter, kita memasuki ISOMA nanti sampai pukul 1 pada sesi paralel akan dilaksanakan di lantai 16 untuk paralel A1 sampai A4 ya. A1 dan sampai A1, A2, A3 ada di ruang Jana Loka, ruang ini akan di split setelah ini. Untuk paralel A4 akan di lantai 16. Untuk lantai 17 dikhususkan untuk paralel A5 dan A6. Ibu Bapak silakan menikmati sajian, hidangan yang telah disediakan. Dan kita akan memulai parallel session pada pukul 1 tepat. Terima kasih.